Hi guys, in this video we are going to learn an interesting question from instantaneous center of rotation. As this is our new video, the first video from the instantaneous center, I'm going to just recall what's the theory behind that. But if you don't know what's that instantaneous center of rotation, just watch any other YouTube reference videos to understand the theory areas. However, I'm just going to tell it briefly. So if you have already learned it, just continue this video. If you like to watch any other questions, videos from any chapters, I have given the link in the description below, so you can also use it there. Okay, let's continue this. So when we are considering about the instantaneous center of rotation, what's the idea behind that? Let's say there's a particle or there's a body which is rotating. So let's say this is a particle, it's going to rotate. So here we can directly tell all particles will be having a velocity. So that's the simple idea. If the particle is going to rotate, there are many particles in that. If we take any points in this body, there will be various velocities in various directions as well as various magnitudes. However, the main idea behind this is there will be a point with a velocity 0. That's the point. That point is known as instantaneous center. If we consider a particle which is moving along, however, we can directly tell there is a point. The question is whether that point is inside this body or outside this body. It can be either, which means sometimes it can be inside this body, sometimes it can be in the outside of the body. So the main thing is if the body is rotating, there will be a velocity, there will be a point with a 0 velocity. That's known as instantaneous velocity. Why we need to find that instantaneous center? Sorry, I think I have mistaken. That's known as instantaneous center of that rotation or of that body. So why we need to find that? The main idea is if we find that instantaneous center of rotation, we can directly find the velocity of any particle in this body. So that's the main idea. So first of all, we need to know how to find the instantaneous center of that rotation. For that, we need to know at least two velocity directions from two different points. Let's say there are 2 points A and B. I knew the value or the direction of the velocity in the point A. Let's say it's in this direction, and the point B is in this direction. So from that, we can easily find the instantaneous center of this rotation. So finding that, we need to first draw the perpendicular line for this velocity direction. So here, this will be the normal line for this direction. As well as we need to draw for this velocity B direction also. So if we draw like this, we can directly tell it's going to coincide in this point. So this is known as instantaneous center. So that's the simple idea, which means if we consider a whole body part, let's say if we consider this body, as we all know, the body is only in this size, also it's limited. However, it can be inside the body or outside the body. So let's say if we are considering a particle like this, it would be in this, the velocity of this point would be 0. However, in this example, I'm not taking like this. So it's a point outside the body. So from that, what's the equation we can get? So that's another main point to do this question. So if we are considering this, from this we all know the velocity of this would be 0. From that, we can directly tell this body is moving or it's having a circular path along this instantaneous center of rotation, which means all the particles are from this instantaneous rotation having the velocity at 90 degrees, which simply means all particles are going to rotate about this instantaneous center. So that's known as instantaneous center. So from that, we can directly tell if the body is moving at that omega angular velocity, we can directly tell the VB would be OB, the distance OB, perpendicular distance OB into this omega, OB into this omega. Likewise, we can directly tell BA is equals to OA into omega. This is similar to circular motion. If we find the value, the center of the instantaneous center of this rotation, we can find the value of any velocities of any points. So if we need to find the velocity of this, let's say this is a C point, so we need to join this, and from that we can directly tell as omega is in this direction, this is also going to be this direction, and perpendicular to this. Also we can find the value. How to find that? If we know the value for omega, we can directly tell it would be OC into omega. So this is a simple idea of instantaneous center of rotation. If you haven't understand this, please watch any YouTube reference video so it would be more clear to you guys. So let's read the question. First, I'm going to read the questions. After that, try it in your own. And finally, check your answers with mine. Here you can find a figure. So please copy this figure so it would be easy to continue the question. Hope you have drawn this one. Just I'm going to read the question. Just take notes from this. The two ends A and B, I have marked over here A and B of a rod. This is a rod and this is A and B. These are the two ends of that rod. Are constrained to slide in vertical and horizontal fixed guides respectively, as shown in figure. Which simply means this A end, one of the end of this rod, can only move in the vertical direction only. If we consider this B part, it can only move in the horizontal direction. So locate the instantaneous center of rotation of the rod. That's the first question. Locate the instantaneous center of the rod. After that, hence determine its angular velocity for the configuration shown. So they have given some points which I have already marked that we need to find the instantaneous center first. After that, we need to find what's the angular velocity at theta is equals to 30 degree, as well as OB. They have given OB is equals to 3 meters at that time. So this is the instant they have given. First, we need to find what's the instantaneous center. The next part, we need to calculate what's the value of omega. It's not a difficult question. You can directly apply the theory and get the answers. Just try it in your own. After that, watch the rest of the video. Hope you have tried that. Just I'm going to do this. Let's say how to find the instantaneous center. The simple thing I have already noted here. When we are finding the instantaneous center, we need to first draw the perpendicular line for the velocity in these points. So we knew the velocity's direction for VA as well as VB. When we are considering the VB, it's in this horizontal direction towards right. However, when we are considering the perpendicular line, we can directly tell it's going to be in this here. Also, when we are considering the perpendicular line for VA direction, which means the vertical direction, it would be in this horizontal direction. So we can directly tell that the instantaneous center would be here. This would be instantaneous center. As I have already marked the point O over there, I'm going to take that I, instantaneous center of this rotation. So this is a simple technique. This is not the end. They have also asked what's the angular velocity for this instance. So how to find that? As we all know, when we position the instantaneous center, the next step is we need to use how to find the equation we have already derived. So it's no problem if you don't know the proving methods also. It's the main thing is you need to know from the instantaneous center, we can directly take the velocity of any point of this moving body would be V into Vp. If we take a point from B, the Vb would be this IB into theta dot, which means that omega. So when we are considering this, we can directly tell BB is equals to BI, the length, perpendicular length from the instantaneous center, into omega. The main part is, if you find the value of omega, it would be same for the whole body. If we are considering the omega for this body, from this point, it would be the same. That's the main thing. So please remember this, omega as well as the alpha won't be changed with any points for this body. If the body is moving in this direction or any directions, but in this instant, it would be same for any point. So that's the main point you need to remember. So when we are considering this, BB is equals to BI into omega, as well as we can find the value for BA also. So BA would be AI into omega. So how to find the values? So for that, as we all know, they have already given for BB. Yes, they have given the value. So we can directly substitute BB for 0.5. So we need to find the value for BI to find the value for omega. So BI. So how to find this length? So they have given OB is equals to 3. So this is 3 meter. As well as they have given the theta is equals to 30. From that, 3 tan 30 would be the length of this OA, which is equals to BI. So 3 into tan 30 into omega, we can directly find what's the value of omega. From that, another interesting part is, as we all know the value of AI, the length from the instantaneous point from the A, we can directly tell what's the velocity of A using this omega. If we found the value from this, we can directly substitute for this. From that, we can find the value for BA. So this is a simple question from instantaneous center of rotation. Hope it would be useful for you. If you like to watch any other videos, any other question videos, just subscribe this channel. Thank you.